Okay, so have you ever been looking through like some really old photos and then you see something in the background you totally missed before?
Oh, yeah, definitely. Happens all the time.
Well, imagine doing that with data from a space telescope.
Mm.
And instead of like a random person, you find evidence of a massive cosmic explosion
Whoa.
that no one had ever noticed.
Wow. That's pretty wild. It really does make you think, like, what else is hiding out there?
Yeah, I mean, in this case, astronomers were they were looking through years of data from the Chandra X-ray Observatory,
Right.
which is a telescope that's designed to see these super high energy events.
Exactly. The kind of stuff we'd totally miss otherwise.
Right. And they were focusing on observations from May 15th, 2020,
Okay.
when they found this super fast explosion. They're calling it XRT 200515.
Catchy.
It's kind of crazy to think that something so powerful could go unnoticed for so long.
Yeah, the speed is definitely a big factor here. Most events like this, astronomers call them extragalactic fast X-ray transients. They usually last for like minutes or even hours.
Oh, wow.
But this one was over in just seconds, like a cosmic flashbulb.
Hold on. So I'm curious, what makes those extragalactic X-ray things fast? Is it just like how long they last?
That's a great question. Fast actually refers to how quickly they brighten. Like, we're talking about a super rapid surge of X-rays, and then it fades away just as quick.
Gotcha.
And they're extragalactic because they happen outside our galaxy.
Right.
Which, that makes it even harder to study.
So we've got this super fast, powerful burst happening in another galaxy, and somehow it went unnoticed for years. So it finally led to its discovery.
It's a real testament to the power of AI, actually. Researchers made this algorithm, trained it on known X-ray bursts, and then let it loose on, like, all the data Chandra's collected over decades.
Oh, wow.
Like mountains of data.
I can't even imagine sorting through that much data manually. So this AI basically acted like a super-powered research assistant, just picking out this tiny event in a sea of data.
Exactly. It's like having a research assistant that can just, analyze data at speeds we can't even dream of.
That's awesome.
And this is just the beginning. AI's potential to change astronomy is just huge. But getting back to our mystery explosion here,
Right.
the big question is, what could cause something this powerful and this short-lived?
Well, the article mentions three main contenders, and they all sound pretty amazing. Let's start with maybe the most straightforward explanation. An X-ray burster.
All right, so picture this. You have a neutron star, right? Super dense.
Yep.
And it's pulling gas from a companion star. This gas builds up on the surface of the neutron star, and eventually it ignites
Okay.
in this huge thermonuclear explosion,
Whoa.
which releases this enormous burst of X-rays.
So it's like kind of like a cosmic volcano.
Exactly, except way, way more intense.
Right.
Now, this is a well-known phenomenon, but we've never actually observed an X-ray burster in the Large Magellanic Cloud, which is where this explosion happened.
Oh, interesting.
So if this is what we're seeing, it would be a first.
That's pretty exciting. But there are other possibilities too, right? What about those supermagnetic neutron stars, the magnetars?
Oh, yeah, magnetars are, they're really fascinating. Their magnetic fields are so strong, just insanely strong, that even tiny little shifts
Huh.
can unleash enormous amounts of energy in the form of X-rays and gamma rays.
Wow.
These outbursts are called giant flares, and they are some of the most powerful events in the entire universe.
Wow. So these magnetar flares, they could be super short and incredibly powerful. Sounds like it could be a match for our mystery explosion, right?
It's definitely possible, but there are some things that don't quite add up. Like, for example, magnetars are they're known for their gamma ray bursts. This event was primarily an X-ray burst, so it doesn't quite fit the usual profile of a magnetar flare.
Okay. So it could be an X-ray burster, which would be a new discovery in that galaxy, or a super weird magnetar flare that doesn't quite match what we know. But the article also mentioned a third possibility.
Yeah.
And it's kind of a mind bender. What if this is something completely new?
Ah, yes. The most exciting possibility, and maybe the most unsettling, a phenomenon that we've never seen before.
Right.
I think that could totally change our understanding of astrophysics. What's really fascinating is that this shows just how much we still don't know about these high energy events.
Yeah.
Even if this turns out to be something we already know about, it's really pushing the boundaries of our understanding.
It's both exciting and a little bit scary, right? To think we could find something totally new in data that's already years old.
It really is.
So how do we even start to figure out which of these explanations is the most likely?
Well, that's where the real detective work begins. We have to carefully examine the evidence, starting with the incredibly short duration of this burst. It was only 10 seconds long.
Okay.
And most extragalactic fast X-ray transients, like we were talking about, they usually hang around for much longer than that.
Okay, so the length of the burst is a big clue. What else can we look at?
Well, the energy profile. That's how the intensity of the X-rays changed over those 10 seconds.
Okay.
Does it match the patterns we see with X-ray bursters or magnetar flares?
Right.
Or is it something else entirely?
Okay, so let's break down each theory and see how well it matches up with the clues. Starting with the X-ray burster, is the energy profile of this burst like what we usually see?
Well, not really. The article mentions that the energy profile of XRT 2005-15, it doesn't really look like the ones we usually see with X-ray bursters.
Okay, so that's 1 point against the X-ray burster theory, I guess. What about the duration? Would 10 seconds be a typical length for one of those?
It's possible, but it'd be on the shorter side for sure.
Okay.
Most X-ray bursts last for at least a couple minutes. So, I mean, we can't rule it out completely, but yeah, it's definitely something to think about.
Right. All right, well, let's move on to the magnetar flare theory then. How does that one hold up against the duration and energy profile?
Well, magnetar flares, they're known for being pretty short, so the 10-second burst length, yeah, that fits in pretty well with that idea.
Okay.
But the energy profile, again, it throws another wrench in things.
Oh, okay.
It doesn't quite match the typical signature we see with a magnetar flare either.
Huh. So both theories have like strengths and weaknesses. It's like we're trying to put together a puzzle, but we're missing some pieces.
Yeah, exactly.
What if it is something totally new, though? Something we've never seen before? How do we even begin to evaluate that?
That's the tricky part, isn't it? When we come across something that just doesn't fit with what we already know.
Right.
It forces us to rethink what we thought we knew.
Yeah.
And that's what makes this discovery so cool. We're dealing with a real like a cosmic mystery here.
Yeah, it's a good reminder that we still don't know everything about the universe, even with all our fancy technology and all those years of looking at the stars and stuff.
It really is.
And speaking of technology, the fact that we found this using AI seems pretty important, right?
Oh, absolutely. Think about just how much data telescopes like Chandra collect. It would be basically impossible for humans to go through it all and find these tiny, tiny little differences.
Yeah, it'd take forever.
This really shows how much AI can totally revolutionize astronomy.
So instead of being like overwhelmed by how much data we have, we can actually use AI to go through it and find all the cool stuff hidden in there.
Exactly.
That's incredible. So besides finding these mystery explosions, what else can we use AI for in astronomy?
Well, I mean, it's already being used in all sorts of areas. For example, it can help us identify and classify galaxies, or detect exoplanets, or even analyze the faint echoes of the Big Bang.
That's amazing. It sounds like AI is more than just a tool. It's like it's becoming a partner, a partner in trying to figure out the universe.
Exactly. AI can process and analyze all this data at speeds that we just can't match. It's allowing us to make discoveries that just wouldn't have been possible before.
So this mysterious X-ray burst, it's not only challenged what we know about these high-energy events, but it's also shown us just how powerful AI can be.
Yeah, I think that's a really important point. No matter what XRT 2005-15 turns out to be, an X-ray burster or a magnetar flare or something totally new the way we found it, yeah, that's a big turning point in astronomy.
Yeah, it really feels like we're at the beginning of a whole new era of discovery, one that's driven by the power of AI.
I completely agree. And it makes you think, what else is hidden in all those giant archives of astronomical data just waiting for AI to find it? What other secrets of the universe are we about to unlock?
That's an exciting thought. We've been talking a lot about the X-ray burst itself and what it means for astronomy as a whole, but I want to bring it back to where this all happened for a second. It happened in the Large Magellanic Cloud, right?
That's right, yeah, the Large Magellanic Cloud. It's a dwarf galaxy that orbits our own Milky Way galaxy.
Okay.
It's relatively close to us, like on a cosmic scale.
Okay.
So it's a really cool place to study all sorts of astronomical stuff.
It's like having a whole other galaxy right in our backyard.
Exactly.
And this discovery just makes it even more interesting.
Yeah.
So even in a place that we've studied a lot, we can still find new stuff, new surprises.
It just goes to show that even in the things we think we know, there's always more to learn, more to explore.
Right. I'm seeing a theme here. We've got this crazy, powerful X-ray burst that's made us rethink what we know about these high-energy events.
Mm-hmm.
We've got AI that's changing how we do astronomy.
Yeah.
And even our own little corner of space is still full of surprises.
You've really hit the nail on the head. It's all about expanding what we know on all these different levels, pushing the limits of what we thought we knew about the universe.
Like that. It really shows how dynamic and ever-changing science is.
Absolutely. And for all our listeners out there, I want to leave you with this. If a tiny little burst of X-rays can lead to such amazing insights, just imagine what other incredible things are out there just waiting to be found.
What other secrets are buried in all that data, just waiting for us to find them?
The universe is full of mysteries. And with the help of AI, we're just starting to scratch the surface.
Yeah, so keep looking up, keep asking questions, and never stop exploring the universe. Who knows what incredible things we'll find out there. Yeah, it's wild to think that this, one tiny little event has opened up so many, new things to explore.
It's a chain reaction. Astronomers are now going back and looking at old data, trying to find anything similar that they might have missed before.
Makes sense?
They want to see if there's a pattern or a connection, anything that can tell us more about what we're seeing,
Yeah, and I bet they're ready to point those AI algorithms at even more data.
Oh, absolutely. This just shows how much information is hidden in the data we already have. It's like having a new way of seeing the universe. And it's not just X-ray data either. They're using AI with observations from all across the spectrum. Radio waves, gamma rays, the whole thing.
So AI is finding new events, it's classifying things, it's analyzing data in ways we couldn't have done before. It's really changing how we do astronomy.
And it's only going to get more important. Just think about the next generation of telescopes. They're going to be producing so much data, it'll be crazy.
We're going to need AI just to keep up.
Exactly.
It's almost like this little X-ray burst, this cosmic photobomber, has started a whole new era in astronomy.
I think that's a great way to put it. It shows that even the tiniest events can completely change how we understand the universe.
And the tools we use are just as important as what we find, right? AI is becoming like a partner in our quest to learn about all this stuff.
A partner that's helping us see the universe in new ways. And every time we discover something new, it makes you realize just how huge and complex and amazing the universe really is.
Well, this has been an incredible deep dive. We started with a little blip in the data and ended up talking about the future of astronomy and these amazing tools we're using to explore the universe.
It really has. It's been great talking about all this with you and with everyone listening. I hope this has gotten everyone thinking and asking questions. Who knows what amazing things are still out there waiting for us.
So keep looking up, everyone. The universe is full of surprises.